and welcome to online class of St. Michaels Academy. We are going to do sums related to mechanical equivalent of heat and latent heat. So let's start. Now what is mechanical equivalent of heat? In the history of science, the mechanical equivalent of heat states that motion and heat are mutually interchangeable and that in every case, a given amount of work would generate the same amount of heat provided the work done is totally converted to heat energy. An SI unit of mechanical equivalent of heat is joules per calorie. So we are going to start a sum which is completely based on this mechanical equivalent of heat.
Good morning students. We are continuing sums of heat. So now today we are starting from sum number 9. Question is calculate the amount of work to be done to convert 100 gram of water at 0 degree Celsius to water at 100 degree Celsius. Mechanical equivalent of heat is equal to 4.2 joule. Now one thing you have to be clear that heat required. Okay, first we can find out from here heat required. So heat required is equal to H is equal to M into S into T. That is equal to M is 100, S is 1 because this is water and T final temperature 100 and initial temperature 0. So resulting temperature that is 100 minus 0 and heat unit is calorie. So 100 into 1 into 100 minus 0, 100 calorie. That is coming 10,000 calorie. Okay. Now work to be done. Work to be done. Work is W is equal to J into H. Actually, this is the relationship between work and heat. W is equal to work, H is equal to heat required, and J for mechanical equivalent. So W is equal to J into H. J is 4.2 into 10,000 joule. Okay, 10,000 is coming from here, and don't forget to give the unit properly. So work unit is joule. Now it is coming 42000 joule. Clear? And this is the answer. Now the next sum. Next sum is number 10. A steel ball of specific heat 0.12 has its temperature increased by 0.5 degrees Celsius on falling through a certain height. If J is equal to 4.2 into 10 to the power 7 R per calorie, calculate the height. In previous sum, heat required and work to be done. And this sum, height, when you are considering height, that means a ball was there, it is coming over there, falling down. That means you are considering potential energy, and potential energy is equal to mgh. Okay? And this potential energy here, this potential energy is equal to work done by that particular ball. So this is equal to again J into H. Okay, so now let's start the sum. Let mass of ball is equal to m gram. Height is equal to 8 centimeter. So therefore, potential energy of the ball is equal to m into G into H. Now, m unknown, H also unknown, but G is equal to 980. That you should know. G is equal to 980. Next, what is G? It's gravitational acceleration. And in CGS unit, its value is 980. That's why I have written 980. Now heat produced is equal to M into S into T according to the formula M into S. S given in your question 0.12 into T also given 0.5 and unit of heat is calorie. Okay. Now according to the problem, you can write just now I have said mgh is equal to J into H. So mgh instead of mgh I have coming 18/7 into, separately I have written 10 cube. Okay, if you want you can do this calculation in your own. I don't have any problem, but whatever I have done I am just explaining you. Next, therefore h is equal to, after doing this division it's coming 2.571 into 10 cube centimeter. In your book at last they have converted this into meter. No need to convert this. This is also correct. So please give this answer only.
Now we are going to discuss about latent heat. What is latent heat? The heat required to convert a solid into a liquid or vapor, or a liquid into a vapor without change of temperature is called latent heat. The latent heat of fusion for ice is 80 calories per gram. This amount of heat is absorbed by each gram of ice in melting or is given up by each gram of water in freezing. If you are not understanding now also, please see this graph. Here, this is ice. This is ice and liquid water melting. See the temperature. Temperature is constant, that is 0 degrees Celsius. After that, again temperature changes occur, liquid water, and it reaches to the boiling point of the water, that is 100 degrees Celsius. So again at 100 degrees Celsius, liquid water and vapor, that is vaporization occurs. So here also latent heat of vaporization required, and here latent heat of fusion required. So after the complete change into vapor, again temperature will rise. So this phase is called latent heat of vaporization, and this phase is called latent heat of fusion.
Now, sum number 11. Okay. So, how many calories of heat are needed to make 60 gram of ice at 0 degrees Celsius? So, given M is equal to 60 gram and T is equal to 0 degrees Celsius. In this sum, one thing you should remember, that they have mentioned ice. Ice means at 0 degrees Celsius, there is a question of latent heat that you know. So 80 calorie per gram, this is at 0 degrees Celsius ice, and at 0 degrees Celsius water's latent heat in CGS unit. Okay, so that means heat, in this situation heat required is equal to M into L. L means latent heat of ice. Okay, so M is 60 into 80 calorie. Please remember, if in case of water or ice they are mentioning, if or water they are mentioning at 0 degrees Celsius and conversion is needed, that means you have to consider this latent heat. Okay, so temperature is not increasing, it's at 0 degrees Celsius, so obviously we have to consider only this, that is M into L. 60 into 80 is coming 4800 calorie, and this is the answer. Now the next sum is a kilogram of water at 20 degrees Celsius is placed in a refrigerator. How much heat must be extracted before all the water turns to ice? Latent heat of this into gram. Okay, from 1 kg is equal to 1000 gram. So M is 1000 into 80, that is latent heat calorie. So ultimately it's coming 80000 calorie. This is H2. So therefore total heat extracted is equal to H1 plus H2, that is 20,000 plus 80,000 calorie. That is actually 1 lakh calorie. 1 lakh calorie, and this is the answer of this question.
You need to do all the sums in your physical science exercise book. For subject-related doubts or queries, please email me at shudeshna1.sma@outlook.com. We also welcome your responses by way of your views and feedback on the PPTs or videos at feedback.stmichaelsacademy@gmail.com. So thank you students and have a nice day.